Myself Reshma, Assistant Professor, Department of Chemistry, Majlis Arts and Science College, Puramannur. Today I am discussing about theories of acids and bases. By the end of the class, you will be able to study different theories of acids and bases such as Lex flood theory, Usanovich theory and solvent system concept of acids and bases. And also you will be able to identify and classify different acids and bases. Finally, you can predict the product of some reaction on the basis of these theories. First theory, Lex flood theory of acids and bases. In 1939, Lex proposed a theory of acids and bases in terms of oxide ion donation and acceptance. And in 1947, Flood extended this theory by considering anions such as halides, sulfides. So, we can say an acid is a species which accept a oxide ion or other anions. Then a base is a substance which donate an oxide ion or other anions. And a general reaction is given here, acid plus oxide ion giving base. In reverse, base giving acid plus oxide ion. Some examples are given here. First one, calcium oxide plus carbon dioxide gives calcium carbonate. In this reaction, carbon dioxide is the acid because carbon dioxide accepts the oxide ion, and calcium oxide is the base because it donates the oxide ion. In second reaction, silicon dioxide is the acid because it accepts the oxide ion. In third reaction, SO3 is the acid because SO3 accepts the oxide ion. Next, limitations of Lex flood theory. According to this theory, all acid-base reactions in terms of anion transfer. So, this theory applicable to only such a reaction. This theory neither convenient as proton concept and nor general as Lewis concept. So, these are the two limitations of Lex flood theory. Second theory, this is the Usanovich concept of acids and bases. According to Usanovich concept, an acid is a species that produces or gives up cations or takes up anions or electron, then react with the bases to form salt. Then a base is any substance that gives up anions or electrons, then takes up cations or react with the acids to form salt. So, we can say an acid is a cation donor or anion acceptor or electron acceptor or which neutralizes a base. Then we can say a base is a anion donor, cation acceptor, electron donor. Of acids and bases in terms of Usanovich theory. This is the example for Usanovich theory. In this reaction, HCl is the acid because it is the cation donor and HNO3 is the base because it is the cation acceptor. In second reaction, carbon dioxide is the acid because it accepts the oxide ion and calcium oxide is the base because it donates the oxide ion. In third one, F2 is the acid, Mg is the base because it donates the electron. These are the examples for Usanovich concept. Limitations of Usanovich theory. It is too general and classify almost all chemical reactions in terms of acid-base reaction, but conventional classification of acid-base reactions, redox reaction, etc. are lost here. These are the limitations of Usanovich theory. And finally, solvent system concept of acids and bases. This is proposed by Franklin. In this theory, acid is a species in which a solvent increases the cation concentration and a base is a species in a solvent which increases the anion concentration of the solvent. Commonly used solvents are ammonia and water. So, we can discuss the examples based on these solvents. First one, water as a solvent. By considering auto-ionization of water, two water molecules combine to form H3O plus and OH minus. H3O plus is the hydronium ion, OH minus is the hydroxyl ion. A species which increases the concentration of H3O plus is called acid, and a species which increases the concentration of OH minus is called a base. So, HCl acts as an acid in water because it increases the concentration of H3O+. Here the reaction is given. HCl plus H2O gives H3O plus Cl minus. Here an additional H3O plus formed and concentration of H3O plus increases. Hence, we can call HCl as an acid. Second one, NH3. NH3 acts as a base in water because NH3 increases the concentration of OH minus ion. By adding NH3 and water, OH minus ions, additional OH minus ions are formed, and hence we can say NH3 is a base. Then limitations of solvent system concept. It does not account for the actual nature of the solvent, but it put excessive importance on auto-ionization. Auto-ionization based reactions are always discussing here. And it does not satisfactorily explain behavior of species in solvents like SO2 because it having low dielectric constant and negligible auto-ionization. These are the two limitations of solvent system concept.